Fixed end is there. Now by H lines, I'm doing the fixed link. End is attached. Let us say it is end A. This is end B. The string is attached here. So this point is C. This is D point. Let it load it there. 250 Newton. There also point B also. Load is attached. Of 200 Newton. And just at point E. So A, B, C, D, E, and the angles are given. So the angle is different. So this angle is given as 30 degree. This angle is given as 60 degree. And this angle is given as 45 degree. 30, 60, 45. Okay. So this is the problem given. I have to find the forces in various segments. The tensile forces actually I have to find. Okay, so I need to draw free body diagram. So now for this kind of problems, we need to draw free body diagram separately here, because two free body diagrams cannot be drawn simultaneously. So that cannot be solved unless you draw the free body diagram. So here I will draw a free body diagram firstly with respect to point D, and then I will draw another free body diagram with respect to point B. Now the question is that on which point I should start. Okay, see, at point D there are how many number of forces. First see, through that B or D point, how many number of forces are acting. And let us consider point D. So 1, to another weight, so tension for the end E, and tension for the string BD, and another weight will work. So 3 forces will act from point D, and through point B, one is the weight, then another one tension for BD, then for tension for BC, and tension for BA. So number of forces acting from point B is 1, 2, 3, and 4, and point D is 1, 2, and 3. So as the number of forces are less through point D, so I will start by drawing free body diagram from point D, as there less number of forces are there from point D. So this is the primary concept. through which point the number of forces are less, the free body should be drawn starting from that point. So here I will start from point D, 250 Newton. Tension will be there here, and another force will be there for D here. If that force is TE, then that force is, let us say, for the string BG, so it is BG. The three forces are there. So the angles have already been given. So we will take another ink. So the angle here. So this angle is 45 degree, and by means of the Z angle, the vertical TBD will make 60 degree angle. So that angles have been there, and one force value is known. So the value of TBD and T can easily be known. If I apply Lami's theorem, or can apply or analyze the forces, components of forces, so we can apply Lami's theorem here. So let us apply Lami's theorem. So let us write that point as D. So by from Lami's theorem, the body diagram at D, point D. Here, let's say T divided by sine of angle between other two. Sine. T and sine of angle between TBD and 250, so it is 90 plus 30, 120, and 120 degree is equal to, and let us consider TBD divided by sine TBD and angle between the two forces. So 90 plus 45, 135 is equal to 250 divided by sine 60 plus 35. Good 1.5. Now if we calculate here, T is equal to, so this is equal to this, T is equal to 250 divided by 905 into 0.433 0.012 Newton. And TBD for this two 183. To check this again, 250 divided by 9.05. Okay. Oh, I have made this wrong. Correct it here. Not 433. I have made it sign 150 while doing the calculation, but it is actually 105. So here the answer is coming out as 224. 224.14. So these are the answers. These are T and TBD. Now I need to draw. Now I need to draw the Fibonacci diagram from point B. So now let us do it. Fibonacci at B. $200. So that should be the TBD. Now these two values are same. This TBD and this TBD, because this will cancel out as these two forces are part of the same string, so that will both two will balance each other. So it will the value of TBD as tension for same. Now you see that they are opposite in direction, and as they are same value, so actually when you are considering the whole structure, then the effect of BD is not there. The tensile force will cancel out. Like there is no support reaction forces on the string, because as we have made the string separated for D and for B, so that's why you have to draw the separate diagram of TBD, but they are actually same forces. See, they are opposite in direction only, so they will cancel out actually. So there will be no combining effect of TBD on that whole structure. This is TC, another horizontal force towards the support is TA. Now the angles. Okay, this angle is 60 degree. 30 degree is this angle. Vertical. 30 degree. With these two angles are known and TBD is known. Now see, as there are 4 number of forces, so Lami's theorem cannot be applied here. So the vertical and the forces has to be resolved in horizontal and vertical directions. So now here I'm going to do TC sin 30 plus, so component of the TBD will be there. TBD is known. I will put the value later on. The TBD sin 60. The two forces values have been written. The horizontal component of TC and the horizontal component of TBD both are written here. Now the vertical component of TC, so TC cos 30 degree and the vertical component of TBD, so 200 plus TBD cos 60 degree. So let me check it in whether I have written all the components or not. So TC has got the vertical horizontal component, TC sin 30 and TC cos 30, and TBD TBD sin 60 and TBD cos 60. So all the components have been written here. I have to consider equilibrium. So that point is point B. So I have to write here considering equilibrium at point B so summation of, okay, let me show the direction here also. So this is the x direction and this is the y direction. I have shown this because then I can show that summation of fx0, summation of fy0 by considering equilibrium. Summation of the forces at x direction is 0. So no resultant equilibrium force act. So in the language, if you want to write it, you have to write no unbalanced force acting on x direction. No resultant unbalanced force acting. So I will write that here also. So that means no resultant unbalanced force acting on x direction. That means that no resultant unbalanced force acting on x direction. So here we will get to TC sin 30 degree plus TBD. I will put that TBD value right here, 0, 1, 2, and 60 degree. Now there the positive x and negative x is TA. Okay, so let me check again. TC sin 30 degree plus TBD value has been there. So 183 sin 60 degree is equal to TA is the opposite force acting in the opposite direction, unless either I can write minus TA is 0 or is equal to TA. So they are the same thing. And now I'm equating the forces on y direction and equating it to 0. I will have TC cos 30 degree is equal to 200 plus TBD value is known, 283.012 cos 60 degree. So unknown force is TC only. So from this equation, value of TC can be found. Let me calculate that. So 200 plus 183 into cos 60 336.59. The value of TC is 336.59 Newton. Now, if I put this TC value here, now only unknown is TA. So from equation, let us name this as equation 1. So from equation 1, I will have TA is equal to, I have to put the value of TC here. So TC is 336.59 into cos 30 plus 83.012 sin 60 449. Check it once again. 336.59 into sin 30 168.29 plus this one is 183.0 183.012 into cos 60 91. .50. So value of T is plus 168.29 250. Later on, when you do this problem in the home, please check it whether my answers are correct or not. But these problems can be solved like this.